So we'll jump straight into this first question, but I think what's good is before you each provide an answer, just give an introduction about yourselves beyond what Nadia's just said, I think. So anyway, this has been really interesting. I mean, there's lots of cool technology there. It looks difficult to do is one thing, I think, and there's players out there. So the first question would be good to consider is, there's barriers to entry to this technology. So what do you think Australia could do or New South Wales could do to lower those barriers to entry into the technology area? So,
so I think we need to. We've got this great facility. We need to kind of fund it so that we can encourage companies to use it and universities to use it. So we build the talent. It was interesting that Dr. Lowe was talking about starting off with 10% yield. That freaks me out as a person from industry, but it also just says that it's not going to really be something that instantly gives us amazing technology. It's something that we need to grow and develop and encourage people to use and learn from that.
Yep, so, so I'm, as you heard, head of engineering at Diraq. Just for people who haven't heard, Diraq is a quantum computing company based here in Sydney. So my team, we look after foundry manufacture of quantum chips, IC design, some modeling and simulation, as well as advanced packaging. And so to answer the question, Simon, I would say, yeah, it's probably mostly about know-how at the moment. I think there is a need to develop a bigger knowledge base in advanced packaging in Australia. I don't think we have necessarily a comprehensive knowledge base in the ecosystem at the moment, but it is improving quickly. I think we need people training in this area. I think we need some companies to lay some trails and bring information back to Australia. And I think S3B has a big role to play here. Right? Industry bodies have a big role to play. Just.
it was me.
Oh no,
That's still
picking out.
I might.
Do you want to get rid of this? Yeah, so just mentioning S3B has a big role to play. Aggregating knowledge, consolidating networks. I think this is where S3B is very well positioned to contribute. I'm not sure if you're looking for more work.
I'm Xiaoke Yi from University of Sydney. I'm an academic. So my feeling is, Dr. Lowe has shown a great example how the Taiwan university industry, they can work together and create new technologies, build a platform for advanced packaging. I think we don't need to copy exactly what they're doing. I think we, here in New South Wales, we already got fantastic universities, lots of great staffs. So we have this foundation there, but we do need a platform that academics, industry, companies, staffs can work together, and also government as well. So together, so we can, I believe everybody wants to contribute, right? In such a raining day, so we got so many audience come here. Taxi, Uber, train, everything come to Redfern, because we want to work together, do something good for the country, right? So we already have this faith in our mind, and we already have, that need from the society, from the growth of industry, from the R&D, from the research, every aspect. But we don't have a platform. My feeling is we got, S3B laid great foundations already, but whether we can have a platform like this Taiwan, Dr. Lowe's one, we can each, parts, we can contribute, we can work together and put all our efforts, into it and create something which is, unique to us. Yeah, thank you.
So Sarah Shah, as mentioned, I work for Safran at the moment as chief engineer for some of my time. For the last few years I've been in defence, working for those big multinationals like Safran and Thales. My background is a lot of sense, or the last 25, 30 years, an awful lot of sensing. Gosh, there's so many familiar faces in this room. It's quite sort of taking me back. So I've been in Australia for 15 years, hence I know quite a few of your faces. One of the reasons I know them is that I did spend sort of 10 years or so working for, when I first came over, working for Solana, heading up their new product development and operations for a while. So yeah, I've been fortunate, very, very fortunate to work over the years with, or be able to work and interact with some of the world-leading research organisations like IMEC and Palo Alto Research and Max Planck when I was in Europe, of course CSRO since I've been here. So yeah, working on a lot of different types of power devices, high voltage devices, and whilst we during that time did actually spend quite a bit in Taiwan, quite a big time in Hsinchu, and have visited Italy in the past, and working with advanced packaging. So hence why I'm sitting here today. But yeah, in terms of lowering barriers, obviously. It's been mentioned already and by the panel and also by Dr. Liu that the partnership is sort of absolutely key. And from any product development, in fact, having key partnerships, collaboration, technologies are so complex today that you can't be an expert in everything. You don't want to be an expert in everything, so you need to be able to collaborate. So any sort of anything that can help with that, and I'm so pleased to see the way the universities have developed over the last 10-15 years since I've been here in terms of being much more collaborative with industry. Things like IP, they're just not issues anymore. We can manage all of those sort of things. So, and of course Australia is very good at collaboration. So I think with partnerships with, particularly for advanced packaging, with equipment manufacturers. I love the model that IMEC has, that they work very closely with the equipment manufacturers, the tool manufacturers. They have those latest state-of-art equipment in-house. They're able to evaluate those and use those for development of those new processes. Of course, being close to understanding the applications, there's as well. So having links into those final. Understanding the requirements of the applications and then designing the processes accordingly is important, even down to the point of being able to know, what sort of environmental specifications does this need to withstand? Is it mill standard? Does it need to go from -45 to 125 degrees? What sort of environmental testing do I need to do? So there's certainly there's a wide range of types of partnerships, but then. Love what's happening with ITRI, seeing the AMRF Building relationship there. So sharing of that expertise and being able to bring knowledge into Australia via those sort of technical partnerships as well.
All right, great. Thanks a lot, guys. And I suppose one big barrier is having a facility, which I forgot to mention, that Ben already talked about, but that's going to be a big kickstart. I'm going to skip the order of the questions I had written down just because Chris already brought it up, but sort of one of the barriers is know-how and talent. So have you guys got any sort of insight on specifics of things we can do to train people and sort of generate that talent, which isn't particularly present here yet? Is the ways we could sort of push that through and generate a bunch of people who know what they're doing in this area as well?
I think, we're going in order?
You mentioned about education. I'm pretty keen about that. So I thought, this is my question.
That's yours.
Xiaoke.
Sorry, no.
No. Oh, okay. Yeah, so I think it comes down to education and perhaps leveraging the new facility early on as a way to train people. But we also need to get people to come in and help with that expertise. It doesn't just grow. So it's a sort of a dual thing. We need to have get people interested that are here, students and so forth. But then we also need to actually get some expertise, either as visiting academics or as people that have some sort of limited tenure or something like that at the facility, so that we can, share knowledge and also bring up that next generation. I should also say that in the design space, a lot of, people that have gone overseas and learnt something have brought something back to Australia. So a lot of people who have started up businesses and that sort of thing in design space in semiconductor here in Australia went and got that experience. So encouraging students to go overseas and then bring it back as well is really important.
I agree very much with what Ty's saying. I think talent exchange programs are going to be very important. So as good as it is to train people up from scratch, we do need kind of an immediate exchange of expertise. And so I think that can come in a variety of forms, but it needs to be in a partnership with a well-respected research institute like E3, like IMEC, like Escott, and it needs to be mutually beneficial, I think, to make it really worthwhile. I think we also need to have some pilot projects underway as well. Encourage companies to take that leap, and then when we have that kind of arrangement where companies might be subsidised, or it sounds like I'm asking for money now. When you've got encouragement for companies to go out and try those new things, then I think that's going to inherently build a knowledge base in Australia.
S3B, has run some micro-credential courses for design. I think we can use the same model for the advanced packaging. So these are the short courses, so it can be probably offline. Online or offline. Kind of like a block mode, that type of training I believe can be provided. This one can be done by collaborating with university, apparently. Yeah. The other one, as Tara mentioned, that student come to the company and also company to employee to do the training. This two-way communication, two-way collaboration, definitely useful. So in this way, students will gain experiences from the industry, and also industry understand more, the first front end of the technology. So these are also good approach.
Yes, I think picking up on the same point really is that certainly the importance of modelling and simulation. I've seen that firsthand from the designing work that we've done. We're talking about thermal modelling, talking about optical modelling, where we're integrating photonics as well. Also, I guess lowering in terms of lowering the barrier, but also training up staff. The cost of those licenses is very expensive. So if there's a way that startups can get access to lower license costs as well, maybe with some assistance, then that's similar to what we've seen on the micro-credential for the cadence, which is great.
Thanks. And I suppose I think I know the answer to this. We should probably be doing all of this right now, right? Instead of waiting a few more years.
Yes.
All right, next question I suppose is around, just looking at what we've seen this afternoon as well in the presentations, there's scope for all sorts of new technologies as well as just sort of increased performance. Do you think this is where Australia can sort of, pull on the innovative strings and really sort of promote some novel technology and devices through this capability, rather than trying to sort of play catch up with companies overseas, for example? Go in order. Why don't we switch order?
Yeah, I'm not saying anything.
Well, I would probably just mention that you don't have to do everything. You can innovate in many different areas. You don't necessarily need a complete line. I mean, when you think about whether it's the equipment, the processes themselves, you know, even if you think of something like DRE, Bosch, when they invented DRE, they then licensed that. You know, just that one process enabled so many more applications. When I would work with IMEC, I'd be going to IMEC for a specific expert, not necessarily a specific process, not necessarily the whole process line. So there's a lot of expertise can be built up in blocks. You don't need to do everything. It's just one of the points I think I would make. And yeah, look, I think it's for in terms of where we can add value. I suppose there's a couple of areas which are maybe the less highly sung areas that but have certainly come up again and again for me. I mean, even things like yes, you're building up the 3D package, but then we've heard a bit about substrate preparation, dicing. So even things like stealth dicing, where you can get those very narrow streets and low damage to your packages. There's a lot of innovation that can happen potentially in those areas as well, and again, they're just sort of individual process steps. So, yeah, maybe we don't always need to sort of go for the very complex. Happy to pass.
Okay, I resonate with what Sarah said. You know, we don't need to do everything, and we also don't need to, you know, sometimes don't need to chase something, because something what we thought we should chase probably will be out after 5 years, because technology just develops so quickly, and you know, previously NVIDIA was a small company, and now it's the second largest company in the world, just behind Microsoft and above Apple, right? That's a great example that innovation really can change the world in a very short way. So as academic, you know, working in the university, I can have the confidence to say that our research in Australia really, I can't say we're best, you know, at the front of the world. So, but we do like facilities and schemes and things and so on to help the researchers to transfer the technologies from the lab to the market, to the, you know, basically that channel a little bit blocked. So I can see from today's presentation, from Ben's talk, you know, particularly, so there will be a, you know, this advanced manufacturing or advanced packaging, this type of capability will help academics to do that, because it's laid from the foundation, such as from the material process to the device and so on and so on. So if we can have that translational research channel open when we design these advanced packaging facilities, then that will be extremely useful for us. For example, if we design something in the lab, we test it, it works, then we can do fast prototyping to do the small scale manufacture and then quickly test the market. So I can, yeah, that's some of my input.
Yeah, so I just add to this that obviously we're not going to be able to compete in volume in this space, but we can definitely compete in terms of innovative solutions, innovations. I think that you know, the defining characteristics of some of the advanced packaging options are that there is a great amount of design flexibility and versatility. So it does kind of facilitate your creativeness in this field. So I think there is a great opportunity for us to compete as a nation in this space. I think, you know, in the quantum realm, we've been blessed with sustained investment for, let's say, 25 years, and so that's built up quite a large number of very creative and innovative professors, researchers, engineers. So I have no doubt at all that when we get this kind of technology in the hands of these creative people in the quantum technology space, that we will be able to accelerate our advantage that we currently hold.
That as well, that so with the move towards chiplets and the multi-chip modules, that also you're increasing diversity effectively. So you're increasing the opportunity to add small pieces of technology to that overall solution. You obviously picked up on the quantum there as well, but yeah, the fact that some of those substrates, they're requiring quite different challenges that we're experiencing. We see there's quite a lot of sensing anyway, that you might have thicker substrates or semi-transparent substrates, so you want to access the substrate from both sides. So those sort of having a more flexible processes and packaging processes that can adapt to those. And to some degree, yes, they're going to be driven by the application and the need of the application. So that could be a niche area, but yeah, still a very potentially they can deliver a lot of value in the enhanced performance. And then in other cases, you might find that same process can be used on a number of different types of say sensing devices. So picking the topics we're going to work on and having the right partners to drive those through to then access global markets, of course, is
important. Also, just, I mean, as long as there's no great expectation for us to earn money from this facility itself, I think it has the ability to allow us to, as everyone said, innovate, try things, give companies an opportunity to have a go at building the dream thing and showing that it could work, and then being able to take that to markets beyond here is probably what this facility would be best at doing.
I think that's a great point. It should be an enabler in terms of what's missing at the moment that is enabling. We've got quite a good design within the community within Australia. We've had that for a while, particularly RF and other areas. But actually build what defence want to see, what everyone really wants to see from is a prototype that's potentially almost ready for field deployable testing, or those representative environments testing. How do you get all the way from that design through to that? That means we need a lot more of these capabilities. And if they're in country, again, sort of a painful experience, a lot of shipping costs back and forward to Taiwan in the past. If we can have that capability here, then that will speed up development and reduce the cost of overall that development as well.
Just to add a little bit more, large foundries are normally based on the PDKs. So the design have to be around the PDKs. If you do something outside the PDK, then you can't do it. Which kind of like limit, startup companies or R&Ds, because we always want to try new things. So if the advanced manufacturing packaging, has that flexibility, at least has some portion of this flexibility, it will be extremely useful and helpful.
All right, this is good. It's sort of a good segues onto the questions. Another one that's probably worth a bit of discussion is it's fairly specific to the different technologies, right? There's all sorts of different things you can do: silicon interposers, redistribution layers, through vias, goes on and on. Have you got any thoughts on how? Like, we can't do all of that. You sort of pointed out already, Sarah, and the AMRF's not going to be able to sort of support all of that technology. So have you got any thoughts on, what areas are most important, or at least, the areas where you think, Australia can contribute to significantly, instead of trying to take that whole swath of technology and trying to do it all, which isn't going to be possible.
Yeah, so that's a tricky one to have a universal view on, but I would say, you know, the 2.5D integration with interposers where they are more active is something that probably does apply to, or is relevant and can provide innovative solutions, I'll use that word, across most of the sectors that we're talking about today. So I think that's kind of where I would place my bets.
And we'll probably just add to that as well that if we can include the photonics element, so into an integrated photonics, because that's I think a lot of the challenges or new mentions of new products that are being thought about here potentially need that. So yeah, so I think we can take some elements of that and have a basic sort of prototype facility line, then that's idea, and even better if it's using the sort of close to sort of the final kind of manufacturing process. But yeah, even if we're just working on some small elements of that, that will essentially key elements of, particularly for defence, is low size, weight, and power. So anything that can make it smaller, but particularly lower power, would be beneficial as well.
Heterogeneous integration related technology can basically package different type of chips on the platform, including photonics, electronics, and radio frequency, the RF chips. Technology related to that.
Yeah, so some of the quantum tech that I'm sort of working on at the moment with some of the startups here is you need not only the photonics, but you need the RF and you need all integrated. So, there's certainly opportunities there for innovation, which are, these are very new tech, particularly quantum is obviously very new as well, so these things haven't been thought of, they haven't been invented already.
Yeah, I think at the edge AI and integrating that with sensing, sort of 2.5D, packaging makes sense. It's for the low, it's doing the swap and size, weight, and power, and a lot of applications now are trying to do all that AI computation right where the sensing is happening, and so it's really an ideal application for this sort of packaging.
All right. Well, it's a start, right? There was a few things mentioned there. Yeah, maybe just probably the last question. I don't know how we're doing for time now yet. That's all right. So again, this is probably specific. It's something that Sarah mentioned there with the chiplets and heterogeneous integration of chiplets. I mean, we can be end users there, right? We can take chiplets and build new devices. We could contribute to materials or science problems on how we sort of build those things and make them work together. We could contribute to the design of circuits and standardization. Do you think it's important for us to get heavily involved in that? And have you got any sort of specific aspects where you think again we could be really we could contribute to the whole field?
You've mentioned standardisation there. I mean, one of the things that with the new material systems that are coming through for things like, obviously we're very familiar with silicon, with compound semi is now pretty standard as well. There's a lot of work in quantum diamond in Australia, which there's other materials that are also being considered as well. So standardisation, achieving a semiconductor grade commercial grade process or substrate is key. So we need, whenever we're introducing a new process, we have to make sure that we adhere by those same sort of standards. There's a whole, we spoke about people earlier, but I mean there's a whole raft of people that are involved in the quality engineers, the reliability engineers, as well as design engineering, R&D. They're all an important part of the solution, and I think can quite often, when we're in that R&D phase, or maybe not that sort of low TRL phase, we're focusing a bit too much. We focus very much on the new and the innovative, but not how we make it reproducibly. And so making one or two of anything is not going to be of value. So I think, yeah, the standardisation is really important. Didn't divert too much from your
No, it doesn't matter.
Can I just add, like, your question was directed to like whether we should do it, I guess, and I would say yes, and why not? You know, this is an opportunity to get into a field that, you know, can make us competitive. It has a lot of pluses. It unlocks creativity, as we mentioned. It unlocks a new type of economics to the development of products, which is, you know, in our favour. You know, there's lots of pluses, and there's a huge momentum in the industry towards chiplets being a cornerstone of the semiconductor industry. So I think, given the opportunity that's in front of us right at the moment, I would say this is a great opportunity. We should run with it.
Yeah, I put in a grant application like 10 years ago about chiplets, and it got knocked back. It was too wild, so I'd be happy to dust it off. Second chances.
All right. Well, I think that's about it, right? Yeah. Oh yeah. So yeah, we'll take questions from the audience for a while if there's any.
Oh, a good discussion. 2 years away from building 2, is that right? A lot of space, bit daunting. I guess the question is, we haven't converged as a community on a clear idea, I think, yet, of priorities, what processes, tools. You're going to need to have a whole bunch of conversations like this. I guess, what's that journey going to look like? Nadia, how are we going to flesh that out and have that really compelling, crystal clear plan that supports research and also has a sustainable business around it? So we've got that alignment. I don't mean to put you on the spot.
It's all right. It was almost like an unanswered question. So actually, one of the things that I was going to leave on tonight was the fact that this is just a first in a series of workshops that we'll be running this year. So we are intending on running a workshop probably upcoming towards the end of July, early August. I was just talking about it with Ben earlier today. And so we will be sending an expression of interest out for people to be involved in that workshop, that series of workshops. We're very keen to have the whole community involved. We would like to hear about what your needs and your requirements are from a capability perspective, and hopefully that will help us start to converge on exactly what it is we're going to be building capability-wise. So hopefully that answers your question.
Thank you. So what I can see from Australia, I don't see any clear strategy in the national level for semiconductor. So we see a good one for hydrogen, a good one for AI, a good one for quantum, but none for semiconductor. Basically, so what we want to do, right? We have a lot of talent, a lot of opportunity, research, but we don't have manufacturer here. We don't have any factory here. Like they build one in Singapore, one in Japan, or 2 in Japan, 1 in Germany, and none in Australia. So basically, is that anything we have to ask the federal government or like what they want to do? Because when you put a strategy there, you put the money there, and we can leverage from that. Lucky in New South Wales we have S3B, and then that is something I understand that when I was here for the last event, there's a guy from federal come in and they said, okay, they will talk to Nadia and learn the model from us and do something. But that is 2 guys, and then they disappear. So is there anything else we can do for the government to put more money, put more thought in that, and then how we can leverage from that?
I iterations of let's do semiconductors in Australia. Really, I guess it comes down to we've got this facility being built, so we should probably try to use that as the thing we all gather around to try to get the funding, get the kind of interest, get the momentum behind. And in the previous iterations, we didn't really have anything to get around except, grumbling about the expensive cadence. So I think, it's a difficult one, right? We've got a country sort of full of little pockets of people who have pockets of expertise, and it's been very difficult to get everyone together because we've got quite disparate needs. And the S3B model is trying to draw everyone together, and now we've got the facility, then that should be sort of the thing we all start to combine around and try to find ways to collaborate and put a lot of momentum. I think we can show that there's a lot of interest, as there is in this room, and perhaps we can use that as a, look, we're doing something, and the politicians interested in that as well.
Yeah, I just add to that, we clearly do need a national strategy in semiconductors. Just coming out of the national strategy for quantum, I think semiconductors is a good next step here. There was a report that was generated a number of years ago that led to the creation of the S3B. Now we have this model in place that's working well. I'm not just saying that because they're buying drinks later, but you're buying drinks later, right? I think this is now is a great time to kind of build the momentum even further and make it known that we do need this kind of national strategy. So very much in line.
Yeah, I'd add to that as well in terms of whatever technologies we're developing, they need to have a business case, they need to have a place where they're going to end up, and they need to have to be able to benefit us, humanity as a whole. That's really about looking. So yes, there's different areas of interest, technology, but there needs to be that pool. There needs to be that pool where we end up.
Yeah, I fully agree with your opinion that we need to have a national strategy for semiconductor, because that will bring the big things, right? Put people more together. But I think it has to start from somewhere, right? And usually it starts from small. So I think with this advanced manufactured packaging, it's not that national, huge scale, but at least we start from something. We also have a small manufacturing related to semiconductor. For example, this Australian National Fabrication Network, AMRF. So me and my student, we make the photonic chips, through the app facilities. Yes, it's small, but we start from something. Yeah.
So that previous question was actually part of what I was going to ask. But the other part is, looking at ITRI, they've got a fairly broad coverage, and they're larger, they've been around longer, but effectively what they're offering is the road for businesses to approach them to do DFM for scale production by testing out at small scale their production. Now this is not something maybe we can do here yet in the short term, but just as S3B is in advanced packaging, it's actually in advanced packaging of capabilities, I think, for Australian and local businesses. I guess the key question I have is, what is your vision as to how we can take what you're building here in Building 2 and that capability to, maybe it's picking winners to some extent, but taking certain packaging technologies and allowing them to actually create a fabrication facility at scale that de-risks a business that's got a new design, wants to do it at a scale bigger than just the tiny thing that AMRF can do, for example, to something which is bigger to basically de-risk DFM for scale production of chiplets.
So I'd say one way to do that is for AMRF to pick its equipment partners correctly and process partners correctly, so that they are representative of what ultimately would be the final manufacturing process. If you're using something that's very, very different, and particularly in semiconductor processing. Every tool is potentially giving you different results, even if they're the same tool. But so don't make it worse. Have a process that is transferable. And I will say we did have a semiconductor line here in Solana. We had a full seamless process line. They developed a silicon sapphire process, and we transferred that process to fabs in Asia. So it's entirely possible for Australia to do similar things in advanced packaging. With help.
Yes. All right. I might actually wrap it up. Unless there is one burning question. Maybe Anna, if we can just get this.
Yes. Just want to ask this one because I'm pretty happy that we're talking about the advanced packaging facilities, but I'm guessing that we left out just on the traditional way of packaging, because I think we want to build up something that is traditional first, build up the experience in the traditional packaging, then as well moving forward to the advanced packaging. Are we tackling first on the advanced packaging, or are we also looking at the way the traditional IC packaging is?
I for one love the dip package and just want to use it. I'm not sure how to answer this question. I guess I don't know what it's going to look like if we can do traditional packaging with what we're getting. I imagine we probably could do some sort of flip chip or something like that. But yeah, it's a good point though. Being able, just having the facility to just package would actually be useful. So yeah, I think that's a good point, and having the baby steps to get to the bigger things would definitely be a good training avenue as well.
I was just going to say, I think we need the roadmap put in place, and Nadia mentioned there's going to be some workshops that are going to be developing this roadmap for capability, and I would imagine it would likely include some fundamental packaging capability on that roadmap. So yeah, it's a good point.
I can see from the presentation, for example, tools such as wafer bonder, die bonder, they can be used for advanced packaging, for 3D stacking thing and so on. But that can also be used for traditional packaging. So my feeling is advanced has already covered the basic. So hopefully, understanding, basically, we already have the base there. So, but just from the presentation that showed today, so the tools they are saying, if they can do advanced, my feeling is they can do traditional.
Steve, can I wait until drinks, or yeah? So I'm just very mindful. We actually do have drinks out there for everybody. I'd like to have everybody join me in thanking all of our speakers. And just finally, before I do wrap up, I do have a couple of messages from the team. So hopefully you're all aware we currently have an expression of interest out for an MPW and CAD Cloud Access subsidy. It is due tomorrow, so we're hoping to see a few more applications kind of come through in the next 24 hours or so. And the other thing I wanted to mention was Dr. Lowe actually said that he'd be very happy to host us all in ITRI. So we actually at the moment are also seeking expressions of interest for people to travel with us to Taiwan in, is it late August, early September. It's aligning with Semicon Taiwan. So last year we went to Semicon, we took a couple of New South Wales-based companies with us. We'll be looking to do the same again this year, but we're also looking to see whether or not we can have a delegation come with us to travel around some of the facilities in Taiwan. So please have a look at our recent newsletter. If you're interested in coming along, fill out the EOI for that as well. All right, thank you all for coming. I hope you stay around for networking. It's been great having you here, and thanks very much for everything.
Yeah.